This is Randy McCullum for IMAGINiT Technologies. Today I'll be going over the new grading optimization tool released with Civil 3D 2022. So what is grading optimization? Well, grading optimization, as I said, is a brand new tool that was released with Civil 3D 2022. It comes with its own executable that is launched through the Civil 3D toolbar. So as you can see, if I go to the Analyze tab on the Civil 3D workspace, there should be a new panel called Grading Optimization. Grading Optimization might not show up by default because it needs to be installed separately. So if you do go to Analyze and you do not see this tab, make sure to either look through your collection permissions on your Autodesk portal or ask your IT supervisor for access to this. Once you install it, then you should see this show up the next time you reload Civil 3D. So, where do I begin with this new grading optimization tool? And what does it do for me? Well, grading optimization has the main prerequisite of the need of an existing topo surface. All grading will be referenced to this topo surface, so you need a surface that covers the entire project area. Once I have the surface, I can do some basic site design by dropping polylines and points on top of the surface boundary to define distinct grading areas. So I'll always have a project grading extents area that is defined by a closed polyline, and then inside of that I will have additional areas that have distinct grading criteria. I also have to have a rough idea of my drainage design. So where am I going to place my low points? What kind of drainage, in which way is my site going to drain? And the nice thing about this is I could do this in phases. I could have dropped in a pipe network with catch basins and then graded everything down to that by setting low points. Or I could just draw lines and drop in points and have it optimize a solution for me so that I could then define catchment areas, figure out what my drainage would be, etc. Then I also want to do things like adding lines to represent curved lines, building pads, pond footprints, elevation offsets and things like that, so that I can then use these criteria when I go on to actually perform my optimization. You'll hear a lot of the term zones in grading optimization because they're the most common type of grading object. Zones are defined as closed polylines, and each zone can be draped on top of another zone with a hierarchy of priority set. So every time you start grading optimization, you will always have a grading limit. That is usually going to be the outer boundary of the entire grading that is defined as one line that's going to meet up with the existing surface. Within that, you will have distinct grading zones that have different criteria for different slope factors or different slope directions. When I run grading optimization, all of these are going to be placed in a hierarchy. Everything at the bottom takes less precedent over everything at the top so that I could layer on top operations. So I could have an overall site definition of 1 to 50%, but then I could have of slope, and then I could have an area with an overall definition of, say, 1 to 50% overall grade, but then within it have distinct areas for ADA ramps, access paths and things like that with a much less severe slope, and it will, as long as the hierarchy is correct, respect those new parameters. And when I place in these polylines, we have to get used to the fact that it does not matter what elevation the polyline is at. They are not included as break line definitions until the optimization is run. We can then create them or make them into break lines automatically but the software is going to optimize the elevations for us. So how do I set up grading optimization, and what is the interface? Well, the grading optimization panel, once you launch it, has a few different buttons associated with it. If I click the Grading Objects button, it turns on both of these two panels. The first one is the tool palette, where all of the definitions of the grading objects are located. So I use this, and I could also just open up tool palettes directly, but I use this in conjunction with the specific types of objects. Points are assigned to Kogo points. Lines are assigned to polylines. I select the object that I want, click this, and click the appropriate object in here, and then assign the definition to it in the next panel. Once I have assigned a definition, I will see all of those objects in an object hierarchy under this new panel called the Grading Object Browser. These grading objects, or grading elements, are defined in three different ways, either via points, via lines, or via zones. Points are Kogo points that you place inside of your existing surface elevation area, and then you can either have it solve for a low point in the area or define a bounded point, which you actually set an elevation target so that your surface will come up and meet it. Under the lines category, which can be either polylines or feature lines, but again, these elevations will then be changed regardless of which object I choose. I can have aligned edges. I can have bend lines, which we'll go over the definition of those in just a minute. Drain lines for draining definitions along a line. Curbs, so I could add my curbs in automatically and create an offset. Elevation offsets to define elevation differences between two disparate zones. And then reveals, which are used in conjunction with building pads to place things like ramps and stairs and things like that. Zones are the most common type that we'll be using, and there is just the only requirement there is that we have to have either a polyline or a feature line that is entirely enclosed. The zone, there's one just called zone that is the most basic, and with that I tell it, what are my slopes that I need to meet my criteria. I could also slope a zone in a specific direction entirely, or near in conjunction with things like drain lines and low points can figure out what my drainage should be across the zone. I could have exclusion zones where the grading is not going to occur. I could have ponds, curbs, which are just like the other polylines, except if I have a closed polyline, it's going to bring up the top of the curb or back of curb is then going to be filled in at that elevation to create things like islands. Building pad locations, grading limits, which are always required, parking lots, sidewalks, and accessible path for ADA ramps and things like that. What type of objects are located, or the definitions are under grading elements points? Low points are just like they sound. You're defining lowest points in a localized area of your optimized grading. You can see here on the image to the right, there are slope lines turned on, so I can see that the slope is sloping toward the low point. So I can place these, a series of low points, and then say if it were in a parking lot, I could just basically define cones of local depression so that I could place catch basins and things like that. And then they're only overridden when you have another drainage line or a low point that is then closer in definition, or if it crosses one of the existing zones or break lines. A wall break line manually. Reveals are used with building pads so that you can place things like ramps and stairs. So here in this image example, there's a truck well coming up to meet a loading dock. And then the truck well reveal line was just placed with the definition of the elevation that you wanted, in this case one fixed elevation, and then it creates a sharp line that you can see for the well and the bay. Zones. As I said, zones are the most common type of object you're going to use in grading optimization. And there is one object called a zone that is the most basic that you would use the most often. When you create zones, you would just draw a polyline, again, that has to be located entirely on the existing grade surface, select it, use the tool palette to assign the zone type to it, and as soon as you do and you have it selected, you see this, much like this interface here, along the left, where you actually apply the parameters to the zone. So in this case, I have set the zone so that it would slope between 1 and 33%. And I've set the outer boundary of the zone to a break line. It'll use this definition depending on the hierarchy, and anything inside of the zone that does not have another zone definition or line definition that supersedes it will meet this criteria of being 1 to 33% within whatever the optimized grading target is for earthwork. Again, these polylines must be closed. So when you select a polyline and you go into the properties panel, if it does not read closed, this will not allow you to add it as a zone. Outside of that, there are specialty types of zones like exclusion zones that used from an enclosed line where you can exempt it from grading optimization. So in this case, I have two roads that were created using corridors. I don't want the elevations of those to be overridden, so I have extracted polylines from these corridors for the outer boundary, joined them together, closed off the ends, and created an exclusion zone so that my elevation definitions and grading are not overridden over my road. Ponds are just what they sound like. I can create a dry or a wet pond based on a closed polyline or feature line that represents the footprint of my pond that I'm shooting for. When I place in the minimum storage and maximum depth, I can tell it whether I want the boundary to change so that it could either shrink or grow the footprint as necessary. I can also add berms. There are additional information. There's the ability to set safety benches for, say, mowing and freeboard requirements to my pond, and it will create the entire grading for me. Building pads, just like they sound, and they can either be solved for based on the grading, or they could be a design constraint. If I toggle the elevation setting within the building pad properties, I can set a range of acceptable elevations for my building pad. That would make it a design constraint. However, if I toggle this off and then run my grading criteria, the building pad will be assigned last based on the grading, and then the grading around the building pad will be brought up as long as I toggle on level grading with pad to meet the actual pad elevation itself. Grading limits are always required on all jobs, and it could be a grading limit could be a right-of-way limit. It could be the parcel definition, the edges of an overall parcel for a site, and then this line then becomes the extents to which you're grading to. So it basically becomes a line that's draped on top of the existing surface, and then all grading within that must eventually meet that surface as one overall daylight line. You can set it you just have to, when you actually select these zones, a lot of them you'll see the same dialog over again, this basic zone one. In this one, it just automatically, when we create a limit, automatically toggles the grading limit on so that it assigns it as this. Parking lots are another predefined zone option, and all it is compared to the other zones is a zone that has a less severe slope typically, and also includes the depth of material, so we can actually calculate the amount of asphalt or whatever the medium that we're using. It can be used in conjunction with curb definitions. So I would place a zone for a parking lot, then I would place curb definitions on top of it. Once it figures out the overall slope of the parking lot, it would then assign the curb at the specific curb elevation and then automatically create things like islands or the edge of the parking lot. Sidewalks are another type of predefined zone that I can place min and max slope targets on, which will also include the depth of material. And I can also do things like slope it in a specific direction. So for example, if I wanted this section of sidewalk to slope due east, I would toggle on the minimum zone inclination and set it to 0 degrees, which is the definition of 0 degrees from my unit circle. Accessible paths, same thing. In this case, I will use it as a ramp. I have predefined in it the lower and upper limits for what I want for drainage and for ADA standards. And in this case, the inclination direction is set to allow the ramp to actually slope down toward the road, and it will solve for the elevation differences that I have between my road and, in this case, my sidewalk, so that as long as it can solve it within the slope tolerance that I have set, we'll create the solution. One final thing to close this out, just a quick example of a site that I've created with grading optimization in mind to show you how the tools fit together. So I have my site prepared, and I've already placed some of the grading objects. If I go to the Analyze tab, find the Grading Optimization panel, and open Grading Objects, I've applied a bunch of grading objects already, and you can see them as disparate zones right here within the Grading Objects browser. I've also added a few things like curbs and building pad. If I want to see which objects I've selected or created already, I can just expand the object browser, select it, and then you can get the properties of that object. Now I have defined already the outer limits using the grading limit, and I'm just going to drape that onto the existing surface. That's why I'm not going to set any constraints. You can change the name of any of these objects at any point to make them easier to see when we actually launch grading optimization. So maybe I'll do that now and call this object the grading limit. So I have another zone in here where I've actually set my grading. So this will be the lowest, one of the lower priority gradings that will just fix my site so that I'll actually have some drainage over it. Within that, I have more options like the curb, and I've set the curb on top of another zone that I will have 1 to 5% slope on that will represent my parking lot. So let's just add a few more things and finish this and launch the grading. To add the curb on this side, I simply have to select curb and select my object and then by default, the default properties come up. Now you can see in the default properties it doesn't actually show me a half-foot curb, which is what I want. I could fix that by, instead of creating the object, I can hover over the option in the tool palette, right-click, select properties, and then change the defaults. So now in this one, looks like I'm already set, so I'll just go ahead and change this quickly. But I still have some islands that I need to add, and those should then be half-foot curbs because I've changed the default going forward. Let me freeze my parking lines, and let's add the remaining curbs by selecting curb, and then I'll just select the objects that I want, and as soon as I press enter, they end up under the grading object browser, and selecting each individual one will show me the curb properties. Just a few more elements remain. I've already added a curb, or excuse me, sidewalk. I've added a ramp. I have added a building pad with elevation ranges. Now let's add a few drain lines. So I'll just draw a few lines here with arbitrary drop locations where I will drop my catch basins. And then this to here, and we'll draw this one to here. Now the last thing I want to do is, I've got a lot of space over here. When I ran this grading earlier, I noticed that it sloped this a little high, so I'm actually going to add one more polyline in here to relax the slope in this general area. And we'll add this as a bend line. Okay. Now I'll assign my drain lines just as I did my curbs. Again, they depend on the direction in which they were drawn, so it should slope my surface this way to the middle. If I launch Optimize, it's going to ask me to select the existing surface to reference, or just press Enter to use the existing ground that it found, and this will launch the grading optimization. And here's what the grading optimization panel looks like. I can see my existing surface. I can turn it using my left mouse button, and the tools in here, the controls work much like AutoCAD, where I can scroll to zoom in with my mouse wheel, scroll back to zoom out, turn and hold to rotate my object. Now the only thing I need to do remaining is to set my optimization options. So what are my minimum and maximum slope targets across my site? Do I want to balance my earthwork? And what is my targeted earthwork balance? I'll just set everything to balance it to 0, and I'll try to optimize smoothness. The other thing you would do in that panel is select the number of iterations you actually want to solve. Depending on the complexity of your surface, you may want to increase or decrease the amount of iterations. If you have a lot of zones on top of each other and a lot of offsets and a lot of lines, each iteration is going to take considerably longer than the iteration before it. But for my purposes, just to run it, I'm going to set this to 10,000 right now. And with the complexity that I have, I should be able to get close to solving that. Now, the only thing remaining is to optimize the surface. Now, as soon as you launch Optimize, You can see the contours as they change in the default view. Clicking down here, the visualization toolbar shows me the options for visualization. I can turn on flow lines, and I can change to things like, say, the slope or the aspect, so I can see which way things are sloping, which in this case, because I have slope lines on, is a bit redundant. I can also set the cut fill, and as you can see, as I zoom in, my surface is starting to take shape. It looks like my islands are starting to form, and the amount of mass change is becoming less and less as I reach convergence. So right here you see a convergence plot. My target, of course, is 0, being the optimal solution, but I'm getting very close so that now each change, each iteration that goes through is less and less. Now, once I'm ready, or in my case, when the solution ends, and I check the convergence plot, if I'm happy with the result, I can send this optimized solution to Civil 3D. I'll select a style, give it a name, and just to prove to myself that it works, I'll look at the object viewer, and you can see our newly graded Civil 3D surface. Thank you for watching this as part of our Elevate conference. Please visit us at our website to see a whole host of additional training materials, as well as services available related to Autodesk, architecture, and engineering design.